In the name of God. Hello, dear students. My name is Masood. I am a physics teacher. We are in Fairhouse website. Have a plan to explain the curriculum of physics, grade 12. So far, we talked about, let's say, some subjects in chapter 1. We talked about, for example, circular and rotational motion. And right now, let's say, I'm sure you can distinguish between rotational and circular motion. And I gave you a key for recognizing, let's say, these motions from one another and distinguishing them from one another by, let's say, by taking a look at the position of the axis of rotation. I told you when the axis of rotation lies within the object, so the object has a rotational motion like Earth rotates about itself. Let me show you the Earth globe. So in this situation, let's say axis of rotation is located inside the Earth. That's where Earth rotates, let's say, about itself. I don't say it circles about itself because it's rotational motion. I can say the axis, let's say the axis of rotation lies within the object. This is rotational motion. But what do you say about the, for example, motion of the motion of the Earth about the, for example, sun? Motion of the Earth about the sun, or motion of the moon about the Earth, right? Motion of the moon about the Earth. For example, imagine there is a moon, for example. Imagine this ball, for example, represents the moon. In this situation, moon, I can say, I don't say rotates. Moon in this situation circles. You see, it circles the Earth. In this situation, axis of rotation, it doesn't locate inside the moon. Axis of rotation is beyond the, let's say, moon, right? Axis of rotation for moon, actually, for circling, while the moon circling the Earth, axis of rotation does not lie within the moon. It's located within the Earth. So circling any planet about the sun or circling any moon about its planet, this is circular motion. So we have two, let's say, expressions for. So we have two expressions for circular motion. I can say circle. We have two verbs actually. You can say moon circles about the Earth, and I can say moon orbits the Earth. So orbit and let's say circle. And there one more, let's say, example. We have a ball actually. This ball is attached to a string. Whenever you, let's say, you circle it, you see, I don't say you rotate it. I say whenever you circle it. So in this situation, the object circles, right? And in this situation, axis of rotation, this string, in this string represents the axis of rotation, and the length of this string, represents this, let's say, radius of the circular motion, right? Let me show you another, let's say, show you a poster. I have a poster. I brought a poster for you, poster of solar system. There is the sun, right? And these are 9 planets. This one is, let's say, Mercury, the sun. This one's Venus, this one Earth, Mars, Jupiter, Uranus, and Saturn, and so on, right? They are planets. I can say planets. I have to say planets circle the sun. Planets orbit the sun. All of the planets orbit the sun, and all of them, let's say, circle the sun in counterclockwise, except for 2. Except for Venus, this one, the brightest, let's say, celestial object in the, let's say, in sunset and sunrise, Venus. So except for 2 of the planets, all of the planets, let's say, circle counterclockwise. So they have positive direction. But Venus and Uranus circle the sun in a clockwise direction. So clockwise means negative direction, and counterclockwise means, let's say, positive direction, right? Right now, by this introduction, actually, I'm gonna, let's say, explain the new subject, which is convergence between the measurements. And in general, you know what the conversion is, and conversion actually in physics matters. Actually, it's very important in physics. Sometimes we need conversion, and I explained it for you last lecture. There are three scales for measurement, actually. There are three measurements for, let's say, measuring the angle of rotation, and you know the angle of rotation is the, let's say, is the criteria for describing the circular and rotational motion. Angle matters, actually. We describe the circular motion and rotational motion by means of angles, right? Angle of rotation matters. And there are three, let's say, measurements in physics for angle, actually. The first one, degree, and we are familiar with degree. The second one, rad. Rad is new for us, actually. And rev, or revolution. Right now, I'm gonna, let's say, explain the convergence between these measurements. The first one, conversion between rad and degree. Between rad and degree. Right? Let me explain it for you. Right? So right now I'm gonna explain the first conversion, which is conversion between rad and degree. I brought a schedule for you. I brought a small table. This table represents a fraction, actually. It's a fraction. Numerator, denominator. Numerator, denominator. So pi in rad is equivalent to 118 degree. Right now, what's unknown here? We wanna, let's say, measure the angle in rad, right? So there are three, let's say, known quantities versus one unknown quantity. How do I calculate theta in rad, actually? By using cross multiplication, actually. If you cross multiply the fraction, anything that multiplies the variable, it goes to the denominator directly, and the other, let's say, variables or numbers goes to the numerator. So theta in rad is equal to pi multiplied by theta in degree, like this, divided by 180, because 180 is the coefficient of a variable. That's why it goes to the denominator. And I want you to memorize this rule. This rule, let's say, describes the conversion between rad and rev. Let's say, prepared an example for you. Example number one. Convert 60 degree into radians. How do I convert 60 degree into radian? By using this equation. I write the equation first, actually. Firstly, I say theta in rad. So just substitute 60 instead of this variable. So theta in rad is equal to pi over 180 multiplied by 60. Here we can simplify 60 with 180. This one becomes 1, this one becomes 3. So pi over 3, this is our, let's say, our angle in rad. So 60 degree is equivalent to pi over 3 rad. And if you want to, let's say, simplify it more, no problem. You can substitute 3.14 instead of pi and divide it by 3, and you need, let's say, you find another value of pi over 3 rad. And I have let's say, advice. I have an advice for you, actually, especially you are grade 12 and you want to participate in national exam, actually. In these situations, I try to try to find more than one answer, right? Because sometimes in national exam questions, there are more than one answer is true. There are more than one option is true. That's why here, pi over 3, you can convert it to, let's say, to a decimal fraction, actually, by substituting 3.14 instead of pi and find another value. This is my advice to you, actually. And we have some tips here. I wrote some tips for you. The first one, angle theta takes two values. It takes two values, 3.14 rad and 180. And beware, look here, beware of using 180 in the rules. It's forbidden. You are not allowed to use 180, let's say, in place of pi, especially in rules, because these rules are devised only for rad, right? Not for degree. So whenever you put 3.40, you see, let's take a look at the previous example. Whenever you substitute, let's say pi by 3.14, right? 3.14 divided by 3 becomes 1.05, and the unit remains as it is. So by putting or by substituting pi, by substituting 3.14 instead of pi, the unit does not change. The unit remains as it is. Keep in mind that pi, let's say, is equal to 3.14 rad, right? But actually, of course, whenever you substitute pi with 180, not in this example, actually, I'm not talking about this example. In some situation, we have to, for example, use 180, no problem. In this situation, whenever you put 180 in place of pi, the measurement converts to degree directly, right? Let's move on to another tip. Tip number 2. It says avoid. You see, I explained it in advance for you. Tip number 2, avoid using 180 degree in equations because they are devised for radians. I explained it for you. Number 3, in calculations, when the angle is given in rev and degree, they should be converted to rad. Of course, they are not allowed in SI. Only rad is accepted in SI. So whenever you let's say observe rev and whenever you encounter degree, you have to convert it to rad, right? That's it. Example number 2, convert 3 pi rad into degree. You see? So this is the opposite case of the previous example. In the previous example, right? In the previous example, what do we have? What do we have? Let's say in the previous example. In the example number 1, it says convert degree to rad, degree to radians. But right now it says convert radian to degrees. Radian to degrees. There are two, let's say we have two ways for finding the answer of this question, actually. There are 2 ways. The first one, let's say without changing the fraction, without changing the rule. Because this fraction, you see, let me tell you about this fraction, pi over 180. This is a conversion factor, actually. Conversion factor for, let's say, from degree to radian. This is constant ratio, right? So, teacher, what shall we do when we have, for example, opposite case from radian to degree? Shall I rearrange the equation? Shall I change the rule? No problem, as you like. I solved this problem by 2 ways, right? By 2 ways. The first way, that's the first way. I didn't change let's say, rearrange the equation. I just, let's say, write the equation as it is, like this. Theta in rad is equal to pi over 180 multiplied by theta in degree. The same rule. I just copy, let's say, paste it. Right now, it says 3 pi in rad. So instead of this number, I say 3 pi is equal to pi over 180 multiplied by theta in degree, because we want to look, let's say we want to find theta in degree, like this, right? So in this situation, can I cancel theta with theta? Yeah. Excuse me, pi with pi. We can cancel out pi with pi. And theta becomes what? Becomes 3 multiplied by 180. And, or you can cancel it here, no problem. The answer will be 540 degree. This is the first one without changing the rule, right? But right now, because we have opposite case actually, I want to, let's say, rearrange the equation. The same equation, I want to rearrange it for what? For degree. I say theta in degree is equal to anything. I told you, this is a rule in mathematics. Anything multiplied by pi goes to the, let's say, denominator. So pi goes to the denominator. Right now, this is the new rearrangement. I want to rearrange it. And the other, let's say, numbers goes to the other numbers go to the numerator. What are the other factors? Theta in rad multiplied by 180. 180 multiplied by theta in rad. You see? So we found new, let's say, new arrangement of these factors actually. I cannot say this is a new rule. I say this is the rearrangement of the previous rule. Whether you solve the problem like this or like this, no problem, as you like. Let me solve it for you. Let me change the color of the marker. Theta in degree is equal to 180 divided by pi, right? Multiplied by what? Multiplied by 3 pi rad, 3 pi. So can I simplify pi with pi? Yes, it can be. 180 multiplied by 3 becomes 540 what? Degree. You see the same answer. So it doesn't matter whether you choose this one or this one, as you wish. Now it's your turn actually. I'm gonna, let's say, give you a homework and I want you to solve it for me. Now it's your turn. Convert 1 rad into degree. 1 rad into degree. I'm sure if you memorize the definition for rad, you can convert it directly without any rule, right? Because 1 rad is equivalent to 57.3 degree without any, let's say, without using any rule. You can find it, but if you use this rule, actually, no problem. If you use this rule, this is homework for 1 rad converted to degree. Whether you write it, let's say, directly, because the value of rad in degree, we have it in the, let's say, definition for rad. That's why it doesn't need to write the rule, right? And if you write the rule, no problem. If you use this rule, write this one. So let's look here. Which conversion factor is used here? Pi over 180 or 180 divided by pi? Which one? Actually, because you look for degree, that's why this one doesn't work. This rule does not work. You have to invert the fraction. What do I mean by this? You have to, let's say, use this equation here. Theta, for example, you forgot the value of 1 rad in degree, but you know what the rule is. Theta in degree is equal to 180 divided by pi multiplied by theta in rad. You see, theta in rad, we have 1. Just write 1 here. So the answer will be what? Theta in degree is equal to 180 divided by pi multiplied by 1. 180 divided by pi. And pi here, I told you, keep in mind that pi takes 3.14 in each rule. Mostly rules are devised for pi, for 3.14, not for 180. So you are not allowed 180 here because you have a rule. Here you have to, let's say, substitute pi with 3.14. And whenever you divide it, you get the value, which is 57.3 degree, right? That's it. 1 rad into degree. Sometimes in national exam question actually, I've seen that some options, let's say, in some options, I've seen that, for example, they give you 53.7 degree, right? Let's say, be very careful actually. Be careful. We have 57.3, not 53.7, right? I'm gonna solve, let's say, some questions in a national exam question, actually, that involves this number, not the real number. That's why I want you to be very accurate to, let's say, memorize the value of rad. Right? Thank you for being with us till now. Let's say explain the second type of conversion, which is conversion between the rad and rev. Right? So does rad have to do with rev, or does rev have to do with, let's say, rad or not? Of course, they have to do with one another, and we can convert them into each other actually by using this fraction. Actually, this is a fraction, but let's say I drew a table for better understanding, for making the situation easier for you. I just, let's say, drew a table here. So this is a fraction. This is numerator, and this one is denominator. Right? So this is a numerator of the fraction. This is denominator. Numerator, denominator. So 2 pi rad is equivalent to 1 rev. Teacher, what does this value come from? How do you know 2 pi rad is equal to 1 rev? Because I told you in previous lectures, think about, for example, full circle. We have a circle actually. We have a circular path. They are coordinate system actually. We have x-axis and y-axis. I told you positive x is the reference line. What do I mean by this? You start measuring the angles from here. So this is 0 level, right? This is 0 level. This is 0 degree, right? Let's say, go here, come here. This one is 90 degree. Of course, they are in degree actually. I'm talking about the degree. This one, half a circle, 180. What do you say about 3/4? Actually, this one, 270. And whenever you reach your original position, whenever you retreat, right, the angle becomes 360 degree, and is called actually one full circle, or one turn. You can say one turn, one full circle, or one revolution. It can be, right? So one full circle or one full cycle, one revolution, is equivalent to 360 in degree, right? But right now, what do you say about the rad? Let's say, write the equivalent value for these numbers in rad, right? I'm gonna, let's say, write these values. For example, 0, it's 0, yeah? 0, it's not, it's the same. Here, one slice is equivalent to pi over 2. One slice, pi over 2. What do I mean? One quarter, actually. One quarter from the circle is the pi over 2. 2/4 or half circle becomes pi, right? Pi. So whenever the object, the rotating object, whenever the object, let's say, traverses a half circle, actually, it means it travels pi rad, and it travels 180 degree. What do you say about this one? In this position, we have 3 pi over 2, because each quarter, this quarter is equivalent to pi over 2. This one, pi over 2. So we have 2 pi over 2, 3 pi over 2, 4 pi over 2. And here, whenever I say 4 pi over 2, means 2 pi rad. So 360 is equal to 2 pi rad. One full circle is equal to 360 degrees on 2 pi rad. That's why I say 1 rev is equal to 2 pi rad. So right now, I look for what? I look for theta in rad. This is our, let's say, variable. Anything multiplied by this let's say, variable goes to the denominator. So 1 goes to the denominator, and denominator of 1, it doesn't, it's not written actually, denominator of 1. So just multiply 2 pi rad by theta in rev. And this is our rule. So theta in rad is equal to 2 pi multiplied by theta in rev. This is the rule for, let's say, converting between, let's say, rad and rev. Let me solve the problem for you. Example number 1. Convert 2 rev into radian. 2 revolution into radians. We can say 2 turns. 2 turns. It can be. So theta in rad is equal to, we obey the rule. You have to write the rule first. 2 pi multiplied by theta in rev. So write 2 here. So 2 pi multiplied by 2 becomes 4 pi. 4 pi rad. That's it. It's very easy. Yeah? 4 pi rad. And I told you, I want you to, let's say, convert pi into the 3.14, right? In order to get another answer. And let's say, by doing so, you find another value for theta in rad. And that's it. Question number 2, example number 2. Convert 3 pi rad into rev. We want to convert rad into the rev. So what's our goal? What do we look for? We look for theta in rev. Teacher, shall I rearrange the equation, or shall I write the equation as it is? No problem, as we like. Here, like the previous, let's say, case, we have 2, let's say, options. We have 2 ways actually. The first way, without, let's say, changing the rule, just copy paste the rule like this one. Theta in rad is equal to 2 pi multiplied by theta in rev. So actually, question is opposite to the previous case. In the previous case, we looked for what? We looked for radian, right? Right now, we look for rev. That's why, no problem. You just write the original rule and substitute, let's say, the value of theta in rad instead of the number here, instead of the variable. 3 pi is equal to 2 pi multiplied by theta in rev, right? So theta in rev is equal to 3 pi divided by 2 pi. 3 pi divided by 2 pi becomes 1.5 rev. That's it. We have one more, let's say, way for this situation. Let me, let's say, write the rule for you. Whenever you look for what? Whenever you look for theta in rad. In this situation, you have to say theta in rev, right? Excuse me. We look for theta in rev. Whenever you want to find theta in rev, right? Theta in rev, you have to divide theta in rad by 2, right? Let's say, just rearrange the equation. If you memorize this, actually, if you memorize this equation, let's say you can rearrange the equation for theta in rev. So theta in rev is equal to, I told you, this one becomes a coefficient of variable. That's why 2 pi goes to the denominator, and theta in rad goes to the numerator, like this one. Let me substitute the value for you. Theta in rev is equal to, theta in rad, we have 3 pi divided by 2 pi. Pi, let's say, cancel out pi, and 3 over 2 becomes 1.5 revolution, 1.5 circle or cycle or turns, right? That's it. Now it's your turn, actually. I'm preparing, let's say, homework for you. It says convert 1 rev into radians. 1 rev into radian. Let me tell you something. Actually, let me explain. Let's say a very important note for you. Uh, Whenever you observe rev, the word rev, right? Revolution. Whenever you observe rev without any, let's say, effort, without thinking about any rule, just write 2 pi instead of the rev. That's it. So the problem will be solved just by substituting 2 pi instead of rev. That's it. Believe me, it doesn't need to write the rule. It doesn't need to, let's say, think about the, let's say, the rules. It doesn't need any effort, actually. It's very easy. But take, let's say, keep in mind that rev, whenever you observe rev, let's say substitute 2 pi uh, instead of the word rev, and the question will be solved in this situation. Actually, when you look for radians, actually rev takes 2 pi rad. And that's all for today, guys. Thank you very much for watching this video, and take care. Goodbye.